Hi, okay, today we're going to be using our Taylor series and our Maclaurin series in order to write polynomials, okay, for functions. And the most common ones you see on the AP exam are these functions where f of x is e to the x, or f of x is sine of x, or f of x is cosine of x. Okay, there are others that you can memorize, but these are the ones that are generally stressed on the AP exam. Now remember that you can always develop them yourself, as we went through one for, I think it was like the ln of 1 plus x or something in the examples that we did do for a natural log before. Or we did do for sine before. Maybe we'll be doing for cosine, but at least now you know that it can be useful to memorize these. So I'm going to give you some tricks. Okay, so here's the first one. E to the x. There's no other letters other than E. Sine has S-I-N, cosine has C-O-S. So no other letters. Let's talk about x0 power over 0 factorial. Okay, and then we just increase. So we work from 0 to 2 and so on. Okay, now 0 factorial and 1 factorial are the same as 1. So you don't need to divide anything there. And x to the first is just x, and x is 0 power is 1. So as you can tell, that little trick helps you. You have now started to write out your polynomial. Now for the nth term, as you notice, you had like x is 0, x to first, x to second, and so on. So it would be x to the nth power. And we're dividing by the numbers that the powers were. So it's over n factorial, and there we have it. Okay, so we got the easy one out of the way. Then we have cosine and sine. Sine of x, cosine of x. Well, cosine, it starts with a C. And alphabetically, C comes before S. So I'm going to try to memorize that one. Okay? Well, the cosine of x uses even numbers in the denominator, okay? Just like, and it starts the same denominator as e to the x, so it makes sense to do this one next. We have 0 factorial and 2 factorial, we do the evens, okay? 4 factorial, that's supposed to be a 4, and 6 factorial, okay? So if you're doing that, it makes sense. If you need to write the nth term, you're going to have 2n factorial. Okay? So now, what about the numerators? Very similar to before. We have x to 0 power, okay, over 0 factorial. We have x to second power over 2 factorial, x to fourth power, and x to 6. Difference here, okay, so it's not just x to the n, it's going to be x to 2n power, is that the signs change. It starts off with an answer of 1, x to 0 power is 1, and then we have a negative sign. And then we have a positive, and then we have a negative. So in here we need to multiply this by negative 1 to the nth power. So if n is 0, you're going to get 1 as its answer. 1 times 1 is 1. So it makes sense that this in here as a factor would work. So now you know how to write the nth term there. And hopefully this kind of helps you memorize it. I think that writing this out a few times will help too. So that's why I'm going over it. Okay, so now that you know cosine, okay, it starts with 0 factorial, 2 factorial, and they were the evens sign of x. Now we're down the alphabet. It's going to start out with the odds. So 1 factorial and 3 factorial and 5 factorial and so on. Okay, so we're not going to leave it just as 2n where, you know, we work this out. We have n being 0. It's going to be 0 factorial. We need to put a plus 1 here because we really want to start with a 1 factorial in the beginning. Okay? Now, we're going to have x to the first and x to the third and x to the fifth, just like we would do before. So we definitely have x to, it's going to be 2n plus 1, just like we had the 2n plus 1, okay, in the denominator for its factorial. It too has an alternating sign of positive then negative and then positive and then this one of the negative. So you do need to have that negative 1 to the nth power and it'll create the correct sign for each term. So hopefully that helps you. And here we go to an example for today's lesson. Okay. You're probably thinking, she said example. Why are there two? There are two. Okay. So the first one is kind of general. And the second one is more specific. Okay. And even by general, I don't think that's the right description I want to say for example 1. I want to say basic. So let's make sure that we get down number 1 and then we can get number 2 down. So if you need to, you can pause the video. If you already started copying and you're like, why do I need to do that? Then don't. We're good to go then. So in example 1, it says to find the first 4 non-zero terms in the general terms for the power series expansion of the function given by f of x equals 2 over 1 plus x squared. But Miss Felicity, that's not e to the x. Yep, there's no e to x there. That's not sine of x. Nope. Cosine of x. Nope, we see cosine of x over here in this one. So where are you coming up with this? Well, before we did Taylor series or look at when the center was 0 and make it a Maclaurin series, we talked about an infinite geometric series or even the infinite geometric power series. So that's actually what we're going to be looking at over here. Okay, so the f of x must have came from the sum, and our sum needs to be that it's the first term over 1 minus r. Now, I don't need to have the subscript, or it could be a 0 there, so let me just generalize it as a. Well, if I rewrite this function as 2 over 1 minus a negative x squared. Okay, actually I should put the square in there. Okay, let's see if I can fix that for you guys. Here we go. So this makes sense. We don't want to square the outside because then that negative would be positive and then it'd just be 1 minus x squared. That's not what we're given. It's 1 plus x squared. So this means that the first term in our series must have been 2. In R, it's a power series, is negative x squared. Okay, so let's look at our general series here. Okay, so for our geometric series, we have something like this. Well, if R is in terms of x, and particularly it's negative x squared, and a is 2, we can rewrite this series like this. So if they want the first 4 non-zero terms. Okay, so neither one of the terms can be 0. So if I plug in 0 into this expression, okay, I'm going to have this to the 0 power, which is 1, and 1 times 2 is 2. Okay, that's non-zero. Let's keep going because we need 4 of them. If I plug in 1, I'm going to get a negative 2x squared. So I'm going to erase this plus sign and write a negative 2x squared. Now, let's plug in 3. Well, if I plug in 3, then I'm going to have something's not right here because that would be negative. Oh, I plugged in 0 and I plugged in 1. I forgot to plug in 2. Okay, so just make sure you keep track. So I plug in 2. And that's going to leave me with a positive answer, and it's going to be a positive 2x to the 4th. Makes sense. Now let's go plug in 3 now. I finally got there. And then I'm going to stop because this is for the first 4 non-zero terms and the general term. Okay, so don't worry, we'll get there. So we plug in 3, and this is going to leave me with the negative answer. I thought it was. It's going to be a negative 2x to the 6th. So now when it says the general terms, you're going to put plus dot dot dot. I ran out of space. That's where you plug in your general term and then keep it going because it is an infinite series. So what you can do is just leave this as your general term or kind of write it the way that we discovered when I went over those 3 series, okay? So first you see that it's switching back and forth between the negative numbers and the positive numbers. So you have negative 1 in the nth power. Okay, when n is 0, it's going to be a positive answer. Where n is 1, it's going to be negative, and so on and so forth. And it makes sense that you have negative 1 to the nth power from this expression here. Okay, you also have 2 times x to the 2n power, and that's its general term. So this is everything that you want for an answer in example 1. Okay, and we did it by understanding our geometric series. We made it into a power series, and we're able to write our answer. So let's take a look at number 2. Okay, so I'm going to read it again in case you didn't get this one down. Find the Maclaurin series for the function f of x equals the cosine of x squared. So this is where our knowledge of what this is going to be with the cosine of x. Okay, so let's say, since this is f of x, let's say g of x is the cosine of x. And remember, C is closer to the beginning of the alphabet. It's going to start off with that 0 factorial and 2 factorial, okay, and so on. 2n factorial here. And it's going to be x to the 0 power, which is 1, and x to the second power, and so on. Okay. And we're going to switch signs. So this is going to be negative. I'm going to try to stress that. Okay, and that would be positive. So we want a negative 1 to the nth power there. So, good. Hopefully you remembered that. And now we can use this because, okay, f of x is g of x squared. Okay, if g of x is cosine of x and we replace the x with an x squared, then we've got f of x. Okay, so that means that we can replace all the x's with an x squared. Okay, so let's go for it. So I can write an equals. And my first term is still going to be 1 because there's no x squared. Or I should say there's no x. I do see an x in the next term, so I'm going to put x squared there. Okay. You should have at least 3 terms, if not more. So since I only have 2 terms, I'm just going to continue. Now this would be x to the 4th power over 4 factorial. Like I said, at least, so if you want to keep going, you can. All right, and we typically write out the nth term as well, so that is important. You memorize that part too. And I forgot the dot, 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 plus, dot, dot, plus, dot, dot, dot. All right. So we are going to make this a little bit neater because we do want to raise the x squares to each individual power. So our final answer is going to be 1 minus x to the 4th over, you know what, just leave the 2 factorial. That's okay for the AP exam. If you really want to, you can write that as 2. And you can write this denominator as 24, but they become larger and larger, so you don't need to. So if you don't need to, save some time. And you can just leave it like this. Okay, and this was supposed to be x squared, so please fix that. So we would get x to the 4n power there. And a dot, dot, dot. All right. So I was so concerned with my ellipses. They are necessary, so make sure they're in there. But make sure everything else is correct. And let me know how you're doing. Good luck on your practice. Have a great time.